Now we will work on dynamic blocks. Dynamic blocks are one of the more difficult topics in this lecture, so let's start. We will create a simple 100 by 100 cube. We will select it and execute the block command or type the block command. Here we have the name field. We will name it our cube. We will leave everything else as it is. We will select the base point. The point can be here. We will select the cube, press enter, and now we have our block. If we double click on it, we enter the block editor. We have already mentioned this, and now we will use these tools on the side, which are actually new with this version 2.25, to create dynamic blocks and how they are used. Let's show a few examples of what you can actually achieve with dynamic blocks. Here we have a few dynamic blocks. These are just some of the things you can do with them. Let's say these 2D doors, you can rotate them with these arrows, and you can add those arrows yourself. We have 2 screws here that we can move up and down, precisely for some preset distances. Here we have some screw heads, 4 pieces, but we can put them all into one block. So if we come here with the mouse and click, we will see that all the screw heads are actually within one block, so everything we need can be placed in just one block. If we look here in the floor plan, we have a toilet that we can move and which attaches to a line, meaning we can connect it to a wall. We can do the same with our block. We have a drop-down menu which, if we click, we'll see that we have several options. This is the plain view of a specific toilet, so we can change it to another one. We can switch to the side view if we're drawing in a different perspective, and so on. And now if we come over here to the parking lot, we don't need to draw these lines individually. We can create a dynamic block and just move them up and down. These are just some things you can do with a dynamic block. Now we'll show you how to actually do it. Let's go back to our cube. So, the first option, alignment, one of the easiest things. Let's say this is some kind of diagram, a symbol in the diagram. We'll place a line in the middle of the cube and continue with a small arrow. Excellent. We'll pull it back a bit. Or maybe this is some kind of valve. Now we'll add alignment. Alignment is one of the simplest things. We'll select the center point and pull it outward. What does alignment do for us? Alignment allows us to now adjust this cube along this central line. If we press Close Block Editor, save changes to cube, and draw a polyline, the alignment system, we will see that it matches with the polyline. This means we don't have to adjust it again. Let's create one more slanted polyline. Just see this and create it slanted. Now we see that it aligns as well. But sometimes, as you might have noticed, it aligns in the wrong direction. How do we fix that? Let's go back to our cube. We'll double click on it. We'll click OK and the block editor will open again. The next thing we need is flip. Flip is also found in these first options. It's for action parameters. We'll click on flip. We need to add it somewhere. Let's add it here. Let's go to the middle again and extend it downwards, because everything inside it will rotate around that axis. We can place the flip state somewhere in the bottom left. We'll set the number of grips to 1. The only thing we need to do now is align the flip grip. We need to move it a bit down. So you shouldn't touch our alignment. The next thing we need to add is some groups to our flip, which will actually flip around it. We can click on our parameter first. And now we can add, now we actually want to flip. We might want to flip absolutely everything, so we'll select all, press enter. Now we'll close block editor, save changes, and now if we go to the cube, we'll have that arrow we added, and we'll see that we can rotate it. Let's try it on the slanted line as well. Everything works normally. Excellent. Let's go back to the block editor to see what else we can do with our cube. We've deleted all the functions on our cube as well as in model space, so now let's try out some new commands. Let's try the stretch command. For this, we'll need a linear dimension or action, and we can place it in the middle of our cube. We can place it there, leave it on grips 2, and click on the stretch command. First, we need to select our cube. The command we placed in eye distance, we'll press enter. Then we'll choose which side we want to stretch our cube. We'll select this side. And now we need to set the frame for what we actually want to stretch. We will place this and select our cube. We will press enter and our command is actually done. If we press close block editor, save changes, and go to the cube, we will see that small arrow. And now when we pull it, we will see the arrow expand. You can do this for some doors, some windows, some tables, or chairs, so you can have just one object and then expand them as desired. We will do the same thing now for the upper dimension. Let's give it a try. Now we can expand the cube on both sides. A really good thing you can do here is select your distances. You have to do it one by one. Then go down to the value set, distance type. You can now add increment or list here. This means by how many steps it will actually move. So let's say it moves by 10 steps. The minimum distance is 100. The maximum distance is 150. Let's do the same for the second distance, increments. Okay, close the block editor, save changes. Now when we move, we'll see that we can only move in the steps we set. If we go back to the cube and edit the list now, we go to distance, then distance time, list. We'll see that we have a distance value list, 3 dots, and here we can add whatever we want inside. Let's say we want 150, 100, 200, and maybe 300. Let's do the same thing for the other distance list we choose. Let's put 200 here, and we'll put 300. Okay, close block editor, save changes. And now when we test it, we'll only see those distances that we have predefined. Let's go back to our block. The next thing we'll add is a lookup table. If we click here on lookup, we place the lookup table here, one grip, and now we have a small icon with lookup. We'll double click on it, and now this window opens. Here we can add some settings. We have 2 distance settings, so we'll add those. We can enter 100 and 100 here as the first distance, 150 and 150 as the second, and 200 and 200 as the third, 200 as the third. Here we can set the smaller distance as small, and here we'll set it as medium. And here we will put large. If we click OK, we close the block editor, save changes, and go to our cube. Our lookup table will have those values that we can increase. For this distance, we placed a list that limits those values, so it doesn't allow us to have that increase. We'll set the list to none and do the same for the other distance. Let's test it now. Everything works fine. Let's go into the dynamic block to show you one more thing. We won't spend too much time on dynamic blocks, just one more thing to show you, and then we're actually done with them. The next thing I want to show you is visibility. Visibility is a great feature. We'll reset all our previous settings. Let's test the visibility. Take a look at this little box when we test the visibility somewhere. We'll click here. That box unlocks for us. Visibility states are actually the states of our box, our dynamic block. We can have several more. For example, we can rename feasibility state 0 to cube. We can add a new state called circle and another state called cube and a few circles. Now we can edit these states. So if we go to cube, make the system visible, select everything on our screen, it will currently be visible on the cube. If we go to circle, we draw a circle. We make the system invisible, select the cube we had before, press enter, current, it will be invisible on our circle. If we go to the cube, we will see that it changes. And if we go to the cube with a few circles, we can draw a few circles on the side and leave everything visible. Next, we can close the block and save changes. Click on our cube and you'll see we have a few options. It's very simple. I think this function is one of the most useful because it requires the least knowledge and is done the quickest.